Here's a tighter, more focused version of your script, shaped to fit roughly a **** 6-minute narration * while keeping the cinematic tone and key ideas. For generations, astronomers and stargazers have been drawn to a single, enigmatic presence glowing deep within the night sky. Betelgeuse, the crimson giant marking the shoulder of Orion. Its deep amber glow feels almost alive, standing apart from the steady stars around it. There is something unusual about it, something that feels both ancient and unstable, as if it exists on the edge of change. But Betelgeuse is far more than a distant point of light. It is a cosmic titan. If placed at the center of our solar system, its outer layers would stretch beyond the orbit of Jupiter. Its radius is hundreds of times greater than that of the Sun, making it one of the largest stars visible to the naked eye. Yet despite its immense size, it is anything but calm. Betelgeuse behaves like something restless. Its brightness fluctuates in irregular patterns, dimming and brightening in cycles that seem unpredictable. Sometimes the changes are subtle. Other times, they are dramatic enough to capture global attention. And then, something extraordinary happened. The star began to fade. Not gradually, not predictably, but rapidly. Its brightness dropped to levels that startled even experienced astronomers. Telescopes across the world turned toward Orion, searching for answers. Speculation spread quickly. Was this the moment? Was Betelgeuse about to explode? A supernova from a star this close, on a cosmic scale, would be one of the most extraordinary events humanity could witness. For a brief time, it could rival the brightness of the moon, possibly even becoming visible during the day. The possibility was both thrilling and unsettling. Scientists tested models, analyzed data, and asked the same question: was this star approaching the end of its life? But the universe did not follow expectations. The explosion never came. Instead, Betelgeuse slowly stabilized. Its brightness began to recover, leaving behind a mystery, a star that appeared unstable, yet refused to collapse. So what really happened? One explanation pointed to dust. Astronomers believe that Betelgeuse ejected a massive cloud of gas that cooled into dust, drifting directly into our line of sight. For a time, the star had partially hidden itself. But that wasn't the full story. When the James Webb Space Telescope turned its gaze toward Betelgeuse, it revealed something far more dramatic. This was not a quiet, fading star. It was turbulent, violent, alive with motion. Its surface resembles a boiling ocean of plasma. Vast convection currents rise and fall, forming enormous cells, so large they could engulf entire planetary orbits. Bright hotspots flare unpredictably, while darker regions cool and drift across its surface. The star is in constant motion, never truly at rest. And beyond its surface, the discoveries are even more striking. Betelgeuse is surrounded by immense clouds of gas and dust, material violently expelled from the star itself. These are not gentle stellar winds, but powerful outbursts. Entire portions of the star have been cast into space, forming expanding shells that drift outward. One of these massive ejections likely caused the Great Dimming. But it also revealed something deeper. The final stages of a red supergiant's life may be far more chaotic than we once believed. What was once thought to be a slow, steady path toward supernova now appears unstable, marked by violent outbursts and unpredictable changes. The end of such a star may not come quietly. It may arrive through convulsions, through massive eruptions that reshape the star in real time. And still, questions remain. Are we witnessing unknown processes inside massive stars? Is this turbulence a warning sign of an eventual supernova? Or is Betelgeuse simply passing through a temporary phase of instability? For now, we don't know. But what we do know is this: Betelgeuse is not just a dying star. It is also a creator. The material it ejects does not vanish. It spreads into space, colliding with gas, forming shockwaves, and compressing matter. Over time, these regions may collapse, and when they do, new stars are born. In this way, Betelgeuse is part of a much larger cycle. When it finally explodes, and it will someday, it will release enormous energy. Elements forged deep within its core, carbon, oxygen, iron, will be scattered across space. Those elements may one day become new stars, new planets, perhaps even life. Its death will not be an ending. It will be a transformation. For astronomers, the chance to witness this would be extraordinary, a nearby supernova offering a rare glimpse into stellar death in real time. But even now, Betelgeuse is changing what we thought we knew. It is forcing scientists to rethink how massive stars behave in their final stages. It is revealing a universe that is less predictable, and far more dynamic, than we imagined. Because stars are not static. They evolve. They erupt. They surprise us. And perhaps the most profound realization is this: the universe is not finished revealing its secrets. Even the stars we have watched for centuries still have stories to tell. Betelgeuse is one of those stories. A story of instability, transformation, and cosmic renewal. And it is still unfolding.